use this formula. That's integral about four directions, the area 1 and the area 2. But that's not usual that the practical engineer calculates this formula. But we have, I gave many of rules to calculate this. And I think we will spend today the whole day to discuss about the geometric mean values. I think it's a very important size.
Hier ist angegeben. Bei denen hier. Some cable customers give the GMA in their table, yes?
But if you have four cables parallel, or 2 or 3 cables parallel, you have to do it by yourself.
This is not standing in this paper. This is made in our computer program, but not in this paper from this manufacturer of cables. Yeah.
I think we have to do the theory about mean values. I explained here 3 mean values. Only important here is the geometric mean values. What is arithmetic mean value? If you have 100 and 120, the arithmetic mean value is 105.
No. 100 and 120, the mean value is 110.
So
I'm not so tired than our guests, because you have got 8 hours more yesterday, yes? The time difference between Korea and Germany is 9 hours?
11 hours.
11 hours?
11?
Half a hour. Half a day.
11 hours?
11 hours.
20, 11 hours.
Yeah, you have got a present of 11 hours yesterday. Now you are tired. But the most problem is to go back. Then you are leaving every 11 hours. Yeah, when you go back to Korea. Yesterday you got a present of 11 hours. A day with 11 hours more.
Why is it 11 hours? To Peking is 6 hours. Or 7 hours. In summertime and wintertime it's different. It's 6 or 7 hours. I was in China 3 times. Peking time is 6 hours to you. Maybe 7 hours in winter. I was in May. If I come back, I bring with my clock, and my clock has run for 1 year and shows always the time of China. It's so much.
Time delay is 8 hours.
8 hours?
Yeah,
8 hours. Maybe Peking is 7 hours,
yeah.
and Seoul is. I think Korea has only 1 time, like the whole Western Europe.
Seoul in Germany. Yes. 7 p.m. Yes. a.m.
It's 7. It's 8 hours. Yeah, 8 hours. Not 8. So, all electrical measurements shows the root mean square but we will discuss. We will only discuss what is a geometric mean value. How I get the geometric mean value of two values. You have, I have enough paper. So, example. X1 is 10, X1 is 20, G is 10 times 20. Okay. Xn is 10, X2 is 20, X3 is, that's now an example. What is G?
Arithmetic or geometric?
Geometric. We will not talk about arithmetic. I can't read. I am. What we have to do? Here, if I have 3, and then
Root 3.
Root 3. And if you have 4, okay, you have to multiply, and I say always we have to have if x and x1 and x2 is in meters, this has to be in meters too, and therefore if we have meter times meters times meters times meters, we have to do the force, the root 4. Okay. That means we have here G is third root from 3rd root of 6. I don't know. No, it's not important here. It's not important. But this is what is a geometric mean value?
I have a question. Why use the GMR?
Huh?
Why use the GMR?
The GMR, I will tell you at next. I will tell you at next. The problem is we have to calculate this one. This one. And what is this one? Why is there logarithm? How do you call it in English? Logarithm?
Log.
Log? So, here is, if you L and G is it's clear? If you okay, it's if you have a step mean step lng and then you can put okay. That is a second form of geometric mean value. That comes a step near to this lng(n1).
Yeah.
And if I make this with the force, I will get lng is 1/4. It's 3 and then it's 4.
Yeah.
That means I have a summation here. And now we make the next step. This is what you see there for n values.
Ich habe leider meinen Stift nicht mitgebracht.
Achso, Laserpointer.
Ja.
So, if we have, I showed it you for 1, 2, and 3, and if you have n values,
Yeah.
if you have n values, you have to build the root n.
Here, like this.
Yeah.
You have 6 cables
Yeah.
in one flexible cable.
Yeah.
Yeah? 6 different cables.
So, and this is the expression, the geometric mean value from n values. So, where I need this, for what I need this.
For this.
Maybe we have to do this one. If we have 2 conductors with the area, we have to integrate about one area and the second area. How many integrals we have to do? 1, 2, 3, 4, 4. I don't want to show the integral with 4. But afterwards I will give you the geometric mean values as result from other you use only Formelsammlung in English.
Oh.
And
List of equations.
list of equations for the geometric mean values, but you don't have to integrate about 4 dimensions. So, and therefore, that you can see this integration in one direction. Normally you have to do an area to an area. It's 4 integrals. If you have a point and a line, you have only to do 1 integration. If what is a point to a line? If it means if you have a line conductor, if this is one, if a conductor is in this form, and another conductor in this form, current flows in a strip line. I call it strip line conductors. We have a line to a strip line conductor, and then we can calculate this integral. We have only 1 dimension of the integral, and if we do this, we will get here such an expression from the last side here. We will integrate the ln, and so on. And for this line, this is done here. When x1, when x1 is 0, we get here the geometric mean radius from a point to a line, and if not 0, we have to use this formula, and then we get the geometric mean radius. You can do it for all others, for four-dimensional integration. You can do it, but it's not good. It's many work. It's all in a list of formula afterwards. So, next.
You mean the reason to use GMR is calculate GMR easy? Just this is.
Habe ich nicht verstanden.
Ich auch nicht. I did not understand the question.
The reason to use GMR
Yeah, GMR.
is to calculate too easy.
Now, this is easy to calculate, but if you have a double integral, it's already most work to do this. And you have to do to this one here.
Yeah.
You see,
Yes,
if you see here, you have how to calculate this GMR. You have to you have to divide by two areas, and you have to the distance, the ln from the distance, and the two areas. That means you have ln g is area ln about two areas. So that is two areas against one area against one area. And in the next step, I have shown what to do. This one. LNG is, I have to integrate only about the length.
Yes.
That means I have one by length,
Yeah.
ln, lnr, this one this length, and then dr or dx, while this is the x direction. That means we have x, we have and this is shown as an, this gives this formula here. This gives this formula. This formula is derivated here as a geometric mean radius between a point and another. But this formula is afterwards important to combine if you, for example, have some tubes on the electrode arms or at the transformer, from the transformer to the flexible cable, and then you have that's ABC. We only want to discuss A by 2C. This formula here, on the next slide we have is important. We make afterwards out of the integral a sum. If we calculate this geometric mean radius between these two parts here, but that's a step you make after lunch, I think. So, and now we will import, we have copper plated electrode arms and we have tubes in full. Electrode is full. And here we have a list of formulas for some conductors. If you have two full conductors, the GMR is the distance A. G is A. That's the same. That's the same. You have to have the distance between the centers of the tubes or of the whole copper cylinder.
Auch wenn die Querschnitte unterschiedlich sind?
Auch.
Gilt das auch?
Yeah, auch. Even the area is different. But then you have, if you combine, if the areas are not the same, if you combine this together, then you have to look at the areas. So I think we will here make a break, oder? Mr. Tim?
Ja, können wir gerne machen.
With this information here, we will, after lunch, calculate how to do this. There are some formulas, but these formulas are not so easy to explain. Speichern? No. I think we'll shut down the computer.
Aber Sie haben ja schon den ersten halben Tag rum.
Ja.
Aber Sie sind etwas erleichtert, nicht?
Ich hoffe, dass nicht zu schnell geht.
Oh, guck mal da.
Oh.
But